Welcome to day 13 of Math 111. Today we're going to be looking at some elements from the history of mathematics. We're going to be looking at the numeration systems from the past. We'll take a look at the Egyptian numeration system and the Babylonian, Roman, and the Mayan, and then finally the Indo-Arabic numeration system. We'll start with the Egyptian numbers. The Egyptians used hieroglyphics. And we can see in this table, which I copied from your book, the symbols that were used. Starting on the left, you'll see a staff, which was their unit. A yoke represented 10. A scroll represented 100. A lotus flower represented 1,000. A pointing finger represented 10,000. A fish represented 100,000. And an amazed person represented 1,000,000. As you can see, we're working in base 10. To create numbers, the Egyptians replicated copies of the various symbols. So if we think about the number 336, think of it in its parts: 300 plus 30 plus 6. Therefore, you need 3 scrolls, 3 yokes, and 6 staves. So you can see the representation of 336 there on the screen. Their system was a base 10 system like we use today. And when there's more than 10 of a symbol, they traded to the next symbol. So for instance, 10 staves make 1 yoke. And so you can see in this example, on the left side, you've got 4 scrolls, 5 yokes, and 11 staves. 10 of those staves will be traded for a yoke. So you can see then on the right what this looks like. You've got the 4 scrolls, 6 yokes now, and 1 staff. Have you figured out what number this is? Did you get 461? The Egyptians did not have a symbol for 0. This concept had not been developed yet. We'll move now to the Babylonian numeration system. They had 2 symbols. The first symbol that we see here stands for a unit. It's like a triangle pointing downward. The other symbol stands for 10 units. And it looks kind of like an angle, where you might think of a boomerang or something like that. We have these 2 shapes that we'll be using. We saw in the previous slides concerning the Egyptian numeration system that they used powers of 10. The Babylonians used powers of 60. I've got a little table here at the bottom of the screen, and beginning on the right end, notice that 60 to the 0 is 1. The rightmost characters will be their units. And then in the table, 60 to the first power equals 60. So the next group to the left will be quantities of 60. And then we have 60 squared, which is 3,600. So the next group that we will see in our number will represent how many 3,600s we have. And then finally, we've got 60 to the third power, which is 216,000. Let's see how this works. It's hard to visualize unless you're seeing an example. Here on the left, you'll see these Babylonian symbols. And just reading from left to right, you'll have the 2 triangles, and then you have 3 angles and 3 more triangles. You have to read from right to left in order to understand the place value here. And so you can see in this one that we've got these grouped. So you've got the 3 angles and the 3 triangles grouped together. What that represents is 3 10s and 3 1s, or 33. And then to the far left, you've got 2 triangles, and that represents 2 60s. So I've got the calculation here under the text, or within the text. 2 times 60 plus 3 times 10 plus 3. That's 120 plus 33, or 153. Right, you might want to read through that again. The next number that we see here in the lower left of your screen, again, starting at the right and moving left, you've got the 2 triangles and 2 angles, and then we have another triangle. So we break there before the triangle. And then we've got that triangle and 3 angles. All right, that's another grouping. And then finally another triangle. So let's sort through this. In the rightmost group, you have the 2 angles, which is 2 10s and then 2 1s, so 22. In the middle group, you've got 3 10s and then the 1 triangle, so that's 31, but this is 60s, so 31 60s, 31 times 60. And then the leftmost group represents the 60 squared, or 3600. So we have a 3600, and then 31 times 60 is 1860, and the 22. So we add all these together. 3,600 plus 1,860 plus 22 is 5,482. You may want to pause the video and study the slide some more, or go back at a later time. The Babylonians did not have a symbol for 0 either. The concept of 0 came later. The Babylonians did use a symbol as a placeholder to indicate a missing position. And it looked like 1 triangle on top of another. So if you saw that symbol, you need to pass over that particular place value. Let's move to Roman numerals. We still see them today in some instances. You may see them on clocks, perhaps in outlines. Sometimes the number of pages in the preface of a book, you'll see these. In the table down here, you'll see the Western equivalents. So I is 1, V is 5, X is 10, L is 50, C is 100, D is 500, and M is 1,000. I have listed here in a table the Roman numerals from 1 to 10. You can see them. We've got I, and then 2 I's, 3 I's, and for 4, we've got IV. Sometimes on a clock, you'll see 4 I's, but typically you'll see IV. 5 is V, 6 is VI, and so on. So take a moment and study that. In this next table, we skip count by 10. So I have the Roman numerals for 10, 20, 30, etc. So you can see these, X, 2X, 3X's, then XL, L, LX, and so on. Take a minute and study these. Notice that we never write more than 3 of a character together. When a letter representing a smaller value is on the left of a letter representing a larger value, think about subtraction of that quantity. So for instance, XL. X has a smaller value than L. So we think about subtracting. 50 minus 10 is 40. Or if you were to see something like this, XC, that would be 10 taken away from 100, or 90. Let's look at this Roman numeral and talk about how to determine its Western equivalent. MCMXLVII. We want to partition the number into parts. All right, so you have M, and then we make CM another group because that's a smaller quantity on the left of a larger one. And then the next group is XL, for the same reason. X is a smaller quantity than L. And then finally VII. Let's look at the translation of each one of these. M is 1,000. CM is 900. That's 100 taken away from 1,000. XL is 40, as you can see at the top of this screen. And then VII would be 7. So adding these, we have 1,947. Let's look at another one. We have DCCLXIV. Again, we think about partitioning our number into its parts. Right, so D and then CC, LX, and then IV. D is 500, CC is 200, LX, that's 60, and IV is 4. So add these, 500 plus 200 plus 60 plus 4. That gives us 764. Let's think about taking a Western number and converting to Roman numerals. 225. Again, think of it in terms of its parts. So 225 is 200 plus 20 plus 5. Convert each of those to Roman numerals. 200 is CC, 20 is XX, and 5 is V. You see the Roman numeral there, CCXXV. Here's another one. Write 3,456 in Roman numerals. Again, you'll see we're writing this in terms of its parts. So 3,000 plus 400 plus 50 plus 6. 3,000 would be represented with 3 M's. 400, that's 100 less than 500. So we'll write that as CD. 50 is L, and 6 is VI. We just put all these together. MMMCD LVI. Let's move to the Mayan numeration system. Mayan culture existed in the Western Hemisphere. Mayans were typically in Central and South America. They were able to do some advanced computations. They had a calendar, and they were able to predict astronomical phenomena such as eclipses and the equinoxes and events such as that. Their numeration system is based somewhat on 20. And you'll see why I put the somewhat in there in just a minute. The Mayans did have a symbol for 0. So this is a little unique to them. I copied this table from your book. A shell represented 0, and then we use dots to represent 1, 2, 3, and 4 outlined there. Perhaps they used pebbles or small shells or something like that. And then we see a horizontal line for 5, perhaps a little stick or something for that. And then 6 is a stick with a dot over it. And 7 has the stick with 2 dots, and so on. And then 10 is 2 sticks. And then you add dots. 15 is 3 sticks. And we add more dots. 19 is 3 sticks and 4 dots. It'd be 3 5s and 4 1s. Interesting number system here. We have the table repeated here, and then I have the symbols for a Mayan number, and they wrote theirs in levels going up. So you have to start at the lower level, and so that lower level has the stick with the 2 dots, so that represents a 7 ones. And then the next level up, you'll notice there are 2 sticks and 4 dots. So that would be 14. And this next level is 20. The multiplier is 20 here. So that's 14 times 20. The third level here has the shell, so that's 0. And this third level is 18 times 20. That's the multiplier. That's 360. And that sounds almost like the number of days in a year. That's why they have that there. All right, and then the fourth level that we have here, you'll see a stick and a dot, which represents 6. And the multiplier is 18 times 20 squared. All right, so multiplying by another 20 here. So we do all the multiplication and add. So these symbols that we see here represent the number 43,487. We'll look at another example. Here, we'll see that we do have a positional system. We're working with levels, and you can see the multipliers here. The first level is just your units, and then the second level, the multiplier is 20. The third level, the multiplier is 360. The fourth level, the multiplier is 7,200. And in the fifth level, the multiplier is 144,000. So it's easy to keep up with if you think of the 18 and 20s. We're increasing by a power of 20 each time as we go up to higher levels. Here's another Mayan number. So remember to start at the bottom. You've got a stick and 3 dots. That's 8. The multiplier is 1. On the second level, you have 2 dots. That represents 2. And the multiplier is 20. So 2 times 20 is 40. The third level is 3 sticks and 1 dot. That's 16. The multiplier here is 18 times 20, which is 360. All right, so 16 times 360 is 5,760. And then the fourth level, we've got 3 dots. So that's 3, and the multiplier is 7,200. And that product is 21,600. We add these 4 numbers, and we get a sum of 27,408. So you see the Mayan symbol, and then the Western equivalent of 27,408. And finally, the Indo-Arabic numeration. The numbers we use today are descendants of the original Indian and Arabic symbols. You may recall from a previous lesson when we were talking about Fibonacci that Leonardo traveled with his father, who was a merchant, and he learned about the numeration system from this area. He brought the Indo-Arabic numeration system back to Europe back in the 1200s. And so you can see how the symbols have evolved over the centuries to what we have today. So the numerals that we use actually have their heritage in the ancient Indian and Arabic cultures. I hope that you have found the information that we've talked about today interesting. You'll have some opportunities to practice with some of these numeration systems. You may want to go back and listen to parts of the video again. You also can find examples in your textbook.